on here in this picture? The brain, right. So the nervous system, right? Nervous system development. So once upon a time we all look like this, did we? And they color coded for us. So this purplish region is that. And then comes this yellow, then comes this red, and then comes the rest of it. So here they give you the name, and how far along are we? We are at 4 weeks, okay? 4 weeks. Gosh. Most people don't even know they're pregnant at 4 weeks. Agree? All right. So, I want you to know these names, okay? Prosencephalon, mesencephalon, rhombencephalon. So what is cephalon? Cephalon. Brain, yeah. Okay. What do you think going to become of prosencephalon? What part of the brain? Cerebrum. Very good. Is that pretty clear? All right, you can predict it becomes cerebrum. Mesencephalon. That's going to become the mesencephalon, right? It's the same name, agree? And who remembers? Give me a vocabulary that would be related to mesencephalon. Okay. So what's going to become, so give me a vocabulary that relates to the mesencephalon. Remember the four corpora, the four quadrigemina. Yeah, that's going to be the mesencephalon area, right? What about the ventricle system? What's going to be running through the mesencephalon? Is it a lateral ventricle? No, because the lateral ventricle was the cerebrum, right? What do you guys think? Might it be the third ventricle? Good guess, but no. It's going to be the aqueduct. The aqueduct's going to be running through the mesencephalon. Okay. So mesencephalon, then this thing called a rhombencephalon. So what's this going to become? Pons and medulla. Okay. So let's see if you're right. Let's see. Now, how far along are we? We're at 5 weeks, right? 5 weeks. And wow, there's more vocabulary. More vocabulary. So all of this was the prosencephalon, right? Remember the bluish thing in the front here? All of this, we used to be prosencephalon. Now it further differentiates, it further divides into this region. Now you start to see the diencephalon. Anyone remember what's diencephalon? That's going to be your three things. Thalamus. And what's the other two things? Hypothalamus and epithalamus, right? That's going to be the diencephalon right here. Mesencephalon still there. And then these two become the pons and the medulla. Looks kind of familiar? Right? Okay, let's fast forward. 13 weeks. 13 weeks. Same color coding, right? Same color coding. Yep. Sure enough, all of this is going to become the cerebrum, right? Cerebrum. And then inside we have the diencephalon, remember the thalamus? Diencephalon. And then comes this region, which is same name, right? Mesencephalon. And then look at that. Look, it becomes the pons and the medulla. Make sense? Okay. And then fast forward again. Looks now like what you recognize as the human brain, yes? Okay. All these words here sounds familiar. Okay. And here we are at birth. And now we have cerebrum. Deep would be the diencephalon, right? And then the cerebellum here. And this would be now the brainstem. Remember, brain stems have these three regions. That make sense? Okay. So, a lot of vocab words, but I just wanted to call your attention to go back to this picture here. Okay? These words you should definitely commit to memory. Okay? Because that's the very beginning, way back when. And then, of course, you should know what it becomes, right? What it becomes. So let's review. Proencephalon becomes what? The cerebrum. And? Cerebrum and? The thalamus, which is, what's the fancy word for all three parts? Diencephalon. Right? So this is going to become the cerebrum.
Wait, diencephalon means thalamus, epithalamus, and hypothalamus?
Yeah.
Oh.
Oh, okay.
That works.
Yeah, diencephalon is the thalamus, hypothalamus, and epithalamus. Okay? And then the mesencephalon stays the same, right? No change. But the rhombencephalon is going to become what? Become the?
The pons and the medulla.
Yes, pons and the medulla oblongata. Right. Any questions here? Okay, so that's the quickly on the development of the brain. And the rest of the slides are there for you to see, so you need to look at it again, feel free. I'm moving on. Alright. How is the brain tissue organized? What do you see? What and what? Right, gray and white matter. Why do we call it white? Myelinated. Okay, what's myelination means? There's something wrapping around the axon. Okay, so it's fatty substance. Whitish looking, yellow whitish looking, so that's why I call it white matter. So when we say white matter, what part of the neuron are we talking about? Axon. So by default, gray matter is cell body. What else? Dendrites and unmyelinated axon, right? Okay, that's what it is. All right. Now, on the brain, what is most superficial? Gray or white? Gray. So the external sheets of gray matter on the brain called the cortex, right? So when you hear people say cerebral cortex, that's another word for saying the external sheets of gray matter. Okay, so let's take a look at the picture. All right, so here, we're going to take a cut right here. Okay. So what lobe are we cutting through? This is the frontal lobe, parietal lobe, agree? So here, you're going to look at the cut surface. Cut surface. What is this I'm outlining here? That's the cortex. That's the cortex. Ah, look. See how the cortex continues here into here? So we call this, what lobe out here? This is the, right here. This would be the temporal lobe. Right? Does that make sense? Because we're taking a cut right here. That's the temporal lobe, agree? Temporal lobe. So what lobe would this be up here, right above it?
Parietal lobe.
Good, parietal lobe, okay? But notice the cortex dips in here. So what might this lobe be?
The insula?
Yeah, the insula. Okay, so the cortex is continuous because it's on the surface of the brain. Get it? On the surface of the brain, and sure enough, it's all continuous. Cortex, gray matter. And so we call this temporal lobe, parietal lobe, This is the insula, which I told you is another lobe, right? Insula is another lobe. Okay? But it's inside. Remember, we saw that in lab today. It's inside. Half the fold, just like the outside. Alright. In this picture, where else do we see gray matter?
Inside the cortex?
Inside, not the cortex, but inside the brain, right? Deep to the brain. So what do we call, do we still call it cortex when it's deep inside? No, we call it nuclei, aha. Remember last time I had a column here that say CNS, remember that? And I said gray matter in CNS. Okay, so let's review that chart. CNS, gray would be cortex and nuclei. Nuclei is plural for what? Nucleus, okay? And so this is where last time I introduced, from that, for this chapter and next chapter, nucleus is not that structure inside a cell to hold DNA, okay? Nucleus in this chapter is this thing, gray matter, okay? But deep in the brain, okay? Guys, got it? Okay, now what's, yeah, question?
Nucleus can also be on in the cell body of the neuron.
Yes, right, so that structure inside the cell to hold DNA is still nucleus, right? But this chapter, it takes on a new meaning. Nucleus are these things. So they're islands of gray, so I describe it, right? These islands of gray matter get the name nuclei, okay? All right, so let's kind of put it together here. Okay, so around the gray is what color? White. And what's white matter again? Myelinated axon, right? Myelinated axon. Does that make sense? Picture? Okay. So let me ask you a question, true or false? Okay, everyone get a vote? Synapse. Okay. Let's review. Last time, what is a synapse? Someone volunteer an answer here. I need about 5 hands to go up. What is a synapse? Okay, good. All right, so I will popcorn. Nathan, what's a synapse?
It's the tail of a neuron where the signal will jump from the synapse to another dendrite or the cell body.
Okay, okay. So it's the connection between two neurons, right? And it sends messages back and forth, right? So how many, with your fingers, tell me, how many kinds of synapse are there in the body? How many kinds of synapse? I'm talking about functionally, sorry, let me clarify. Functionally, not and anatomy-wise, but functionally. That is how it works, right? How many kinds of functional synapse do we have in the body? Now I'm looking for 2. Functionally, what are the 2? Someone give me one? Chemical and electrical, right? So functionally, it works either by chemical or it works by electricity ions. Okay, now if I had changed the question, say, structurally, how many different kinds of synapse do we have in the body? So look at the anatomy, the structure. We have 3 kinds of synapses, right? In the body. So what are the 3 kinds of synapses? Axon to dendrite, axon to cell body, and axon to axon. Okay. That's it. Can there be any more? No. No other possible combination. Alright, so here's the thinking question. True or false? You will expect to see synapse in gray matter only. True or false? You expect to see synapse in gray matter only. True or false? Okay, so true or false? You expect to see synapse in gray matter only. Okay, the answer is true. Okay, so everyone who answered false, please pay attention. Once again, what do we say is gray matter? Cell body. Dendrites. And unmyelinated axon, right? So we talk about synapse, meaning axon to cell bodies, agree? Axon to dendrites, agree? Or axon to axon, agree? So yes, it's true. Synapse will only occur in gray matter because that's where you have the three possible combinations. What's in white matter? Only myelinated axon, agree? So if you have white matter, like any of this thing here, can you synapse to cell body? No, because there are no cell bodies. It's only myelinated axon. You guys understand that? I mean, by definition, white matter is only myelinated axon. How are you going to synapse to cell body if there's only a myelinated axon? You can't. Okay. So synapse will only occur where? In the synapse will only occur in the gray matter. So in the context of the brain, synapse will only occur in the cortex or the nuclei. Okay. All right. So that's an example of understanding. It's never written in here anywhere, but if you understand what it is, rather than just memorize blindly, then you can logic out the answer. Okay, that's what you need to do. All right, let's move on. Can we go further down the brain? We're going to take a cut right here. Through what? Cut through the cerebellum and the, what's this in front? The pons. So here's the cerebellum, here's the pons. Okay? Wow. The cerebellum. What is this on the edge here? White or gray? Really, on the edge? Gray. So it's just like the brain, right? On the edge is gray. Deep is white. Now let's look at the pons. Is the pons the same? Is this an edge here? Is that gray or white? And it's dim light. At the edge. Remember, the edge here is gray, agree? Is this edge here gray or white? White. It's different, you guys see? So the pons has white on the edge, on the surface, superficial surface. Gray is inside. Okay? And remember, between the pons and the cerebellum, what is the space called for CSF? The space for CSF between the pons and cerebellum. The space for CSF is called the fourth ventricle. Does that sound familiar? That's what it is. The fourth ventricle, watering the tree of life, remember? Fourth ventricle, watering the tree of life. Okay, let's move down a little further. Okay. So this is, they call it fourth ventricle, kind of we're going to continue the fourth ventricle on down. And same deal, right? Here we have the medulla oblongata. Is the edge here white or gray? White. The gray is all deep. So we lost the cortex. And sure enough, cortex only exists where? Cortex only exists in the, no, don't say brain, only exists in the cerebrum. Okay, so now that you're in anatomy, brain no longer is sufficient. Okay, so please don't say brain. Okay, cortex is only in the cerebrum. What the heck is a cerebrum? How is it different from the brain? It's the top part, and it's made up of cerebrum, made up of, okay, so gray matter, gray cortex, lobes, right? Remember all the lobes we talked about? All those are cerebrum. So what are the lobes? Let's rattle off. They're here. This is the frontal lobe, parietal lobe, temporal lobe, occipital lobe, and inside, insula. That's cerebrum. Okay? Yeah.
What does ventricle actually mean?
Ventricle
Like opening or like
is a space.
space? Or
Yeah. Ventricle is a space to hold CSF. Okay? Alright. Okay, so let's continue. Brain has support and protection. Okay, so let's talk about the protection that the brain has. Okay, so first of all, what's outside the brain? The bony cranium. Gee. What, did we study the bony cranium? Yeah. It's called the skull, right? So all of this part is the cranium, agree? So what bone is this? Frontal lobe bone. This bone? Parietal, temporal, occipital. Okay, so that's the bony cranium, okay? Otherwise known as the skull, right? It also has connective tissue membrane. Okay, and they call them meninges. Gonna go into here next, okay? So it's just connective tissue, meninges. And what else? What else is gonna protect the brain? CSF. And what does CSF stand for? Cerebrospinal fluid. Why? Because we find it in the cerebrum and in the spinal cord. Yeah. Uh-huh.
Meninges, is that something that, like, does meningitis have something to do with
Yes, it does. Yes. We're going to go there pretty soon, okay? Hang on to that question. All right, so, and lastly, the brain has another layer of protection, which is what? The BBB. What's the BBB? Blood-brain barrier. Oh, let's review. What glial cell helps with the BBB? Astrocyte. Good. Astrocyte helps with the BBB. Blood-brain barrier, okay? So, with your fingers, how many layer of meninges do we have? How many layers of meninges do we have with your fingers? Correct answer is 3. Okay, and they are what? Dura matter, arachnoid matter, and pia matter. Okay? And it goes in order. From what? From what to what? Superficial to deep. Good. All right. I'm going to ask you to talk to your neighbor. And I want you to make a list from superficial to deep. You know, I love this kind of question, right? Because it really tells me if you know your anatomy or not. Okay, so rattle off the list from superficial to deep. Okay. So go ahead, talk to your neighbor. I'll give you a minute. Make a list.
So, superficial skin stuff, hair skin, just that. Yeah, basically. But after the bone of the skull is the arachnoid.
What? Periosteo. Oh, it's awesome.